Hey everyone, in this video, we'll talk about some techniques in which we can use to collect a good sample from a population. First, let's talk about census versus samples. A census is a count or measure of the entire population. For example, if your study population is Tacoma residents, then a census is data that you're collecting from every single person who lives in Tacoma. It's most of the time it's very difficult to obtain a census. It's because what if the population is too big and you lack of time, tools, and resources to collect information from every single person in the populations? So how can you conduct a study? How can you learn about the populations without a census? An answer for these questions is you can collect a sample. A sample is a count or a measure of just a part of the population. And it depends on the ways of samplings. There could be a lot of different samples of the same populations. And because we're using samples to make conclusions about the populations, there's always sampling errors, which are the differences between the actual population measurements and the measurement that you get from a sample. Right? So that means when you're collecting a good sample, one of the important goals that you want to aim is to reduce sampling errors. The smaller the sampling errors the samples can achieve, the better the results that you can get for your study. So that would make it a good sample is a good representations of the populations. So how can we, collect a good sample? And there are, and again, to reduce sampling errors is a goal. So then in order to achieve the goal, we want to have some strategies. And in this video, we'll discuss some sample techniques, some strategies which we can use in order to collect a good sample for the populations. So there are first random samples. Random samples means you collect the sample randomly from the population, but how random you want to be, right? How can you stratify your random? There's 4 techniques that are common in sampling techniques for random samples. First is simple random, second is stratified, cluster, and systematic. So these techniques are good techniques for collecting a good sample. But sometimes people use non-random samples because of some reasons, some nature of the studies. Sometimes people use convenience samples, non-random convenience, if they need to collect data in a very short period of time. It's very hard to conduct a good, come up with a good strategy for collecting random samples. So maybe sometimes non-random samples or convenience samples or prior experience samples are good enough for a certain studies. So there's 2 different types, random samples and non-random samples. So to illustrate these techniques, I want to come up with a study. For example, if you want to study the average commute time of UW-Tacoma students, how can we do that? We know that the population is about 5,000 students, and is, again, 5,000 is not a big number, but it's almost impossible to ask every single student about how long would it take you to commute to the campus. So then we would like to collect a sample of the size of 200 students, arbitrary. It depends on how much time you have, how much resource you have. You will decide the size of your sample. Okay. In this example, I just picked 200 students. All right. First technique of the random samples, simple random samples. In this technique, every possible sample of the same sample size has the same chance of being selected, which means if you decide the size of a sample, in this case is 200 students, then every subset of 200 students has the same chance of being selected. And how can you guarantee that? A way to execute this technique is to assign each member of the population a unique number, after which numbers are selected randomly. For example, each student has a unique student ID number of 9 digits. Then you can generate 200 random numbers of 9 digits, and then you just poll students who have those two random numbers of 9 digits for your sample. You can use this website here to generate such random integer generations. But you can see that there's an advantage in this case, in this technique, is what if you generate some numbers that do not match with existing ID numbers? Then you have to throw those numbers away, and you have to keep collecting, keep generating new random numbers until you get to 200 ID number for your sample, right? So in this case, this technique is a good technique of selecting a random sample, but it's not. But there are some disadvantages of using this technique. Second, stratified samples. In this technique, members of the population are divided into 2 or more subsets. We call it strata. Each strata share a similar characteristic, such as age, gender, social status, income range, etc. After which a random subset members of each stratum is collected. So if you divide your populations into 4 or some subsets, each of this strata, right? Stratum, it's like age, gender, income range, and so on and so forth. And then in each of the stratum, you collect a random subset of members of each of the stratum. So red dots are representations for the sample, right? You're selecting from each of the stratum. Back to our examples. If you want to, collecting informations about UW-Tacoma students, you can use strata as classes, freshmen, sophomore, junior, seniors, and in each of the class, you randomly select 50 students to have 200 students for your sample. Or you can use majors. There could be pre-major students, business major, sciences, engineering majors, and any others major. And because we have 5 strata, we would select 40 students in each major to be your sample. The next technique is cluster samples. This is a technique in which the population is divided into groups. We call them clusters, after which all the members in one or more, but not all, of the clusters are selected. So these techniques are similar to stratified samples. However, we use these techniques when groups or clusters are geographical locations. For example, if you divide populations, right, into 4 areas, and then you pick 1 or 2 or more areas, clusters, but not all clusters, to be your sample. And then you select all the members in those clusters, in the cluster that you picked for your sample, all of them. In our cases, in terms of locations, buildings make sense when you think about clusters. So on our campus, we have Joy, Jerry Park, Snoqualmie, Dewan, and some others buildings. Then for your sample, you can just pick 2 or 3 buildings. For example, I picked 2 buildings, Cherry Park and Dugan, for my sample for the study. And to pick these 2 buildings, one day come in and I try to ask every single student in these 2 buildings, how long is your commute to campus every day? The next technique is systematic samples. This is a technique in which each member of the populations is assigned a unique number. All the members are ordered in a certain way, and a starting number is randomly selected. So you assign each member a unique number, you order them a certain way, could be from 1 to 5,000, and then you randomly select a starting number. And then the samples are withdrawn from the populations by selecting at the regular intervals from the starting number. For instance, you want to collect members at every third, every fifth, or every 100th member. In theory, for our examples, we can assign each student a random number from 1 to 5,000. And then we select, the first number, right, as the starting number, and then you select every 25 students. So for example, students whose number is 1, 25, 50, 75, 100, and so on and so forth to get 200 students for your sample. But in reality, we have to think about that. In order to have, access to all students' name, even just the name of students, you should have to be an admin to do that, right? Otherwise, wouldn't have any access to all the informations. So systematic samples doing this way is possible, but it could be tricky if you're not one of the not working in administrations. All right, convenient samples is just pick a sample conveniently. In this case, you can just ask your classmates, right? Or students who hang out in the classroom building, your friends in school, and so on and so forth. Anyone that you can talk to, let's say. Convenient samples is a way to collect a sample. But because this doesn't follow any of the strategy, there's no algorithm, there's no strategies, it's hard to collect a good sample using convenient samples. All right, so let's do an exercise. Identify sampling techniques that are used in each of the scenario. The study is, you're doing a study to determine the opinion of students at your school regarding stem cell research. So in each of the scenario, identify the sampling techniques used. First, you divide the student population with respect to majors and randomly select and question some students in each major. So because you divide students in majors, it means each of the majors is a stratum, right? And you have strata. And you just select some students in each major, which means it's a stratified technique. Second, you question students at the library and cafeteria. So library and cafeteria are the 2 locations on campus. And you question all of them at the 2 locations. So that means it's a cluster. So each location is a cluster in your population. And you pick 2 clusters, and you select all the students in those clusters. So it is a cluster sampling. Third, you assign each student a number and generate random numbers. You then question each student whose number is randomly selected. Generate number, assign a number, generate number, randomly select those numbers, then it's gonna be a simple random sample. Okay. Lastly, you question students and you run into them on campus. You don't have to pick an area, you don't have to divide them in majors, you don't have to assign them a number, you just ask students and you run into them. Very convenient, which means it's convenient samplings. All right, I hope that you learn about sampling techniques and be able to apply these techniques into your own statistical study.